Okay. Item B, intrinsic geometry, exterior algebra, extend to R3 and R4. Okay. Today is 25th. Okay. Now let's move to B part 4. Okay. So B part 3, part 2 and part 1 are very, very, very important to understand what you are going to explain here in part 4. See, part 4 is property of the Hamiltonian. It's a very, very, very useful tool for the mechanics and electromagnetism, civil engineer. That's a very, very important subject. You see, properties of the Hamiltonian. B part 4, lecture 1, the phase space or the cotangent bundle Q, attention now, asterisk Q. You see? Now, from the part 3, you derived, okay, these Hamiltonian equations is the first order, okay, equations. So Q dot is partial H respect to P, and P dot is partial H respect to Q. Dot here means derivative with respect to the time. Although for autonomous system, the Lagrangian and the Hamiltonian are not explicitly function of time. So let's then to show that the phase space, the cotangent bundle T asterisk Q. Now, from part 3, we presented H function of Q and P. You see, and the differential H is partial derivative with respect to Q, dQ, partial derivative of H with respect to P, dP. P is the momenta, you see, and Q are the generalized coordinates, you see, represented by QI and PI over here. You see, this is denoting this case. You see, this notation here are represented by dQi, and dP is represented as dPi. Now, general notation, manifold M. Okay, in general, the notation we use manifold M. You see, in differential geometry, okay, in this case, we usually denote the manifold general abstract space as M. But in mechanics, it's usual to represent the manifold as capital Q. In Hamiltonian and Lagrangian mechanics, attention now, okay? It is standard to denote Q as the configuration space, that is, in this case, the mechanics contains points Qi and Q dot I. You see, this here belongs to the tangent space. You see? Now, on the other hand, the cotangent bundle is represented, okay, can be written as T asterisk Q using the Hamiltonian mechanics, okay? Then this contains the points Qi and Pi. Attention now, I here is lower index and Qi is upper index. I'll say in the plural, okay? QI are the upper indices and PI are the lower indices, because I comes from 1 to n. Okay, so this space is 2n. Okay, n for this and n for that one. So the conjugate bundle T asterisk Q is denoted as the phase space. When you say, oh, this is a phase space, what means? It is a cotangent bundle T asterisk Q. See? That's it. Now, these indices, QI and PI, always bother who is taking this for the first time. You see? Now, first of all, the coordinates QI and PI belongs to the cotangent bundle. What bundle means? Okay, this represents, okay, many points on this manifold Q that we call bundle, tangent bundle and cotangent bundle. So, attention now, DQI are a basis, okay, of the cotangent bundle, okay? So DQI is one form. You see, the forms, you'll be a subject of later lectures, as you see. You see, I will expand in this case, the exterior algebra. You see this here, this intrinsic, you see, exterior algebra. You see, I will show, okay, separately of this concept, what means exterior algebra. Okay, exterior algebra is the tools, okay, to work, to manipulate the intrinsic geometry in the cotangent bundle. That's important. Exterior algebra is related to the cotangent bundle. Okay. Now I will reserve, okay, lectures about the general, this case, okay. This is exterior algebra. Okay. Now, so I will explain why I over here are upper indices and PI over here are lower indices. Both belongs to the cotangent bundle T asterisk Q. Okay? Sure, if I'm studying, I'm analyzing at one point, there's not cotangent bundle anymore. So it will be a local representation. See? So DQI are one form. As I said, we'll see when we'll derive, we'll explain the exterior algebra. Okay? So this I call here one form, element of the basis of the cotangent space. Attention now, cotangent space means is the same, okay, as in the space, the phase space. See, as I pointed out before over here. See, so then this is what represent these upper indices over here. Okay. Now at each point, bundle means I represent this for many points that belongs to this manifold Q. And the T asterisk means a special set, okay? A special space, which is called phase space. Phase space is identical, is the same as cotangent bundle. You see? Now comes PI. Attention now. PI are functions, okay, on this space over here, on the phase space. they are the components of the covectors at a point. See? Covector, if you remember, okay, in many videos, many previous videos, I think part 1 or part 2, I don't remember, but covector is the same as a dual space. Dual space or covector means the same. You see, now this is at the point. Thus, Py dqi, attention now, I over here is dummy, okay? This is a linear combination of the bases. You see, this, okay, look, Pi is a functions. dqi is basis vector, okay? This is a linear combination. See, that's a Pi dqi, okay? Now, this is one form, dqi. dqi are the basis of the tangent bundle, okay? And this is very important here. Qi, but dqi belongs to the cotangent space. Attention now. Qi belongs to the tangent space, but dqi belongs to the cotangent space or phase space. So I have this, the coefficient Pi, which themselves vary from point to point. That's why to represent the bundle, okay? So these terms over here, okay, this summation over here, these themselves vary from point to point, okay? Attention now, don't forget that this is cotangent